So in order to explain the models a bit better, I decided to make a screen recording of the same. And over here, we'll start with the EleTech thermal model. I'm sorry for the disturbances in the background. And so this is the dashboard, and the model is 100% complete with data collected for 540 items. And if we go to data acquisition, so here we can see various classes of the data. So this class is of fire. These are all thermal images, and the fire class, to just serve a bit better, we'll go with the B class first. And here are some images of the bees captured. They are all single images of the captured bee. So this is the bees, and then we go and have a peek on the elephants. And so this is one of the elephants, and this is the second one, and there are many more like this. And then we'll check the human class. So this guy has a gun in his hand, so this can be better. This can make the model better if the detected person has a gun in his hand, so that can be a major risk for the elephant. And the last class is the lion class. Here we can see the lion, the thermal images of the lion. Later we go to generating the impulse for the model. So we are generating the features, and the color depth is RGB, of course, for the thermal model. And just have a peek on the feature explorer loading over here. It's taking a bit time to load. And here we go. These are the feature explorers of the model, and all the class are differentiated in the plot. They have a different axis, even for the elephant, even for the bee. They are different in the model. And we can go over here and check the accuracy of the model. So we get 100% accuracy with the quantized model, and with the unoptimized 100% as well, and loss depth to 0.03, which makes the model really useful and accurate. So now we can go ahead and see another model. So let's go ahead and see the seed distribution model over here. And this is used to detect whether the the main diet of the elephant contributing to the seed distribution constitutes of sausage pods, bananas, and custard apples. So here is the data for sausage pod and the data for custard apple. So here's the data for custard apple and the data for bananas. So here's the data for banana and elephant dung over here. So whenever it starts from the fruit and then goes and ends in the elephant dung, so we can calculate the distance between these two images detected, and we know the distance of the seed distribution accurately. So this is used to measure the seed distribution of an elephant and we get an accuracy of 93.5%, just quite good with image models. You can go ahead with the next model, which is the EleTech view model. This is used to detect the view of the elephants, so whether back, front or side of the elephants in the herd. It can be used to so this is an image of the side of an elephant. The other images are there in the documentation, and we can just have a look at the features over here. So let's go to the generated features section, and meanwhile the feature explorer is loading. We can So this is the main documentation page. Over here I've covered all the data set for the images, and you can have a look over here. And these are the features. They are all grouped together, but they are kind of different from each other. A different plane of axis, different area in the plot, so they do not get mixed with other and have a basis of differentiation. And so let's have a look at the accuracy and the loss. The accuracy is 86.3% while the loss is 0.64. Since the image is infrared model and based on grayscale, the accuracy is a bit low, but in the unoptimized model the accuracy is good enough with inferencing time of 704 milliseconds, which is good enough for open MV cameras. So this was one of the model. Then we go with the EleTect object model to detect how many elephants are there, to exactly detect the density of the elephants. And there are three classes multiple together, so in this class there are many elephants. Some of the data is not so accurate, but most of the data is accurate. And finally we get an accuracy of 85.6% with three classes: multiple separate, multiple elephants but separate, multiple elephants but together, and multiple and a single elephant. So this is the least density and this is the most density. So after that we can head to another model, which is the EleTect Accelerometer Model. So before that, let's have a look on the models, and these are most of the models. So before moving to the accelerometer model, I'll show the EleTech distance model. This is used to detect the distance of the herd of the elephant from the actual elephant inside. So there are 5 classes with distances 0 to 5 meter, 10 to 15 meter, 15 to 20 meter, 20 to 25 meter, and 5 to 10 meter. So it's used to accurately estimate the distance of the elephant from the herd. This is too far, and this is the 20 to 25 meters away distance. And like that, there are many other and data in the data set which is there in the documentation. You can have a look at over there. And let's just check the generated features for once. And over here we can use a grayscale dataset because I'm using an infrared model. Over here you can see all the classes are they are a bit together, grouped together, but different in different areas of the plot. So over here you can check different areas of the plot, and they have their own area where they are grouped together, different from other classes. And then we can check the accuracy, which is 89.5%, which is really good, and 95.7% in the unoptimized model. So I guess that's good enough. And now we can go with the accelerometer model. in the accelerometer model, I've collected data for 8 behaviors of elephants. These behaviors are aggressive behavior, elephant falling behavior, whether it's injured and falling, foraging, whether it's angry and running very fast, the must behavior, shake behavior, sleeping, standing, and walking. Walking is simple walking, casual walking, and the data set for the complete model is available in the documentation for a greater look. So here in the mass model there is a random change from the axis in the model, and after studying the um, accelerometer and the behaviors of elephant, I have simulated the behavior for the accelerometer model, and it's pretty simple to do that, since I've gone through 2 research papers which document the behavior of elephants. So after that, estimating the elephant behavior is pretty simple, because in the EdgeImpulse model you just need to the captured frequency, the captured data is the change from the initial state of the model. So um, if the axis is 0 at once and you shake it, so the change is recorded in the model. So it's pretty similar to the real world environment data, and we can have a look at the spectral features over here for the mass model, and frequency, domain, and spectral power. So just this is just to have a deeper look in the features generated, and after going to the feature explorer, we can see a good enough basis of differentiation of all the classes over here. So you can see this class is foraging, falling, aggressive, shake, and in the end the sleeping class and must class. So that's pretty simple, generating the features. The sleeping class is all clumped together, and we can check with the neural network classifier. The accuracy is 96%, inferencing time 1 millisecond, which is good enough for all microcontrollers out there. It's a good enough model, and the confusion matrix is clear as well. We can have a look at the audio models now. The audio model to detect the behavior of the audio. So when one elephant um, portrays a play behavior or a social behavior or an assurance behavior, so in the play behavior we can see there's similarity in the data over here, and even the social and the assurance behavior is similar. You can have a look at the data and the documentation, and this is the accuracy. The accuracy is not too high, but after adding much more data set I'll get a better accuracy. The problem over here is the social class, which is the actual label is social and the predicted label is assurance, which makes the model a bit inaccurate. um, and then we can have a look at the audio v3. The audio v3 is similar to audio v2 v1, and this has 4 classes: alone, anger, bond, and play. Even these are the classes to detect the behavior of an elephant from audio, and we have the accuracy of 72.4% over here. Then we can go and have a look at audio v4. This is a bit different from the other audios, because this indicates the laryngeal and trunk calls of an elephant. These are the laryngeal calls: bark, roar, rumble, and trumpet. They do not signify the exact behavior, but they signify the organ through which the sound is generated, and we get an accuracy of 67.2% here, but the loss is quite high, 1.13, and I'm definitely going to add some data in the trumpet and bark to make the model much more accurate. So this was one of the model, and the other model is audio threats model. So this is the audio of all the threats to the elephant, including bees, guns, humans and lions. So I've collected around 3 minutes of data, 7 minutes of data over here, with some data for human and some data for lions. Lion roars when they see an elephant, and humans when they see an elephant. So, and the data for the gun was the gun firing in the air when they wanted to drive away the elephant, and we get an accuracy of 80.6% with the processing block as MFE, melt frequency energy. And then we can check the EleTect audio distance model. I'm sorry for the blur in the screen recording. So this model mainly detects the distance between the herd and the elephant. So whether the herd calls are near or whether the herd calls are from far away. So it basically detects the amplitude. Over here the amplitude is quite high, and in one of these amplitude is quite low. So it's used for assessment of this, and we get an accuracy of 90.3%, which is good enough. And I'll be adding more data to the class var, and inferencing time is just 1 second, which is good for any microcontroller. So here we complete all the models, and you can have a look at the documentation for a better look at all the models. Thank you for viewing my project.